Hello everybody, I am Tyler Angus, and in the picture you can see Kasem, Tony, and Jonathan, and we are e-scooter team 2. So, just to cover real quick what we're going to go over today, we'll talk about what our overall goal, our prototype, some engineering implementation that we had to do, and some improvements for our future. So with e-scooters and e-bikes taking over our streets these days, there's become an increasing need for safety. And so that's our goal, is to make these scooters and bikes safer. And we're going to do that by implementing a helmet, but not only just a helmet, a smart helmet to motivate the rider to wear it. So we have our stakeholders here. We had riders, the police department, and the manufacturing companies. And we asked them a whole bunch of questions, and we were able to come up with the different types of designs that we could implement that would help solve our problems based upon the information that they gave us. This is our final overall design that we came up with last semester. And as you can see, we have our camera right here. There's a heads-up display giving her navigation, and we have a vibrating handlebars letting her know if there's something behind her that this ultrasonic sensor is detecting. This is a quick block diagram of what we have. We have our battery over here that's going to a voltage regulator, and it's going to power the Jetson Nano and the Arduino Mega. And these are going to transmit to our Bluetooth module, which communicates to the vibrating handlebars. So we'll go into prototyping real quick. This is our final prototype, and most of these little black case, or all of these black cases you see, were done by 3D printing, and we had to design all of them ourselves. This first prototype was very basic. We just wanted to get this ultrasonic sensor right here working, and we wanted it to turn on this vibrating motor over here on whenever it saw something within a certain distance. Our second prototype, which we also got working, is the same thing, except for now we added this serial communication line, and it's talking to the Arduino Mega, which then displays information on this heads-up display. So when it detects something, it not only vibrates the motor, but it tells you on the heads-up display. Then we get into our third prototype, and this prototype was a lot more to it. We got rid of the ultrasonic sensor due to the range restrictions, and we implemented this camera, and we also implemented what's called a Jetson Nano, and that's this really crazy looking board right here. And it is a computer that can do object recognition. This is our iteration. We just wanted to get this thing up and running as quick as possible, and we were able to do that. So this is our final result, and this is what we have working today. I'm going to walk you through this. So you can see our heads-up display here, and it's displaying our speed in kilometers per hour. And as you are looking at this heads-up display, you can see through it. Uh, as you're wearing the helmet, the heads-up display is just above your vision and is easy to see as you're moving. Over here, as we come along, we have our camera. This is the Jetson Nano that does the object detection. This is our battery box. This battery box is super hefty and it has a lot of power, so we can power this whole system. This is our GPS, the blue light right there. And below that is the Arduino Mega. And the Arduino Mega is sending information via these cables to the heads-up display. If we come over here, I have the helmet plugged into my monitor, and you can see that it is recognizing objects, and as I back up, you'll be able to see it recognizes myself as a person, and as it recognizes me, it will only recognize me if it's 70% sure or more. The object detection is able to recognize cars and trucks, and so I'll hold this truck up, and you can see on the monitor it's detecting it. And if you look on the heads-up display, you can see the orange icon is lighting up, and that tells us that there is something to the rear of you. This is our speed, and as we are walking along, you'll be able to see that the speed changes. As I go forward, the speed goes up to 5 kilometers an hour and slows back down. This is our object detection. In real time, recognizing the car, you can see it is recognize the car. It has the little object telling you that there is a car there. And as we move to the right, there's no longer a car behind you, and the object detection turns off. And this is completely on battery power. There's nothing else connected, and this will run for quite a while. And there's the gun again now that the car is back in the view of the camera. The power consumption while doing object recognition is displayed on the right here. You can see our CPU usage is quite high, and our memory is also quite high. So this thing is working pretty hard, which is why we have to have such a hefty battery. We have a 32.6 amp hour battery. We want to thank you for watching our presentation and give a special thanks out to our professors, Dr. Jensen and Jeff Selman. Thank you for your time.